For as long as humanity has been watching the skies, we've been fascinated with the possibility that other worlds, much like Earth, might contain living organisms. While our visits to the moon taught us that it's completely barren and uninhabited, other worlds within our solar system remain full of potential. Venus might have life in its cloud tops. Europa and Enceladus might have life teeming in a subsurface ocean of liquid water. Even Titan's liquid hydrocarbon lakes provide a fascinating place to search for exotic living organisms. But by far, the most fascinating possibility is the red planet, Mars. This smaller, colder, more distant cousin of Earth most certainly had a wet past, where liquid water clearly flowed on the surface for more than 1 billion years. Circumstantial evidence has pointed to the plausibility of life on Mars, not only in the ancient past, but possibly still living, and perhaps occasionally active, even today. And now, in a groundbreaking revelation, NASA's Mars rover just found something shocking that no one can explain. That discovery leaves the whole scientific community astonished. Join us as we dig deep into the latest stunning discovery of NASA's Mars rover. Just blows your mind. Mars, the fourth planet from the Sun, is a dry, rocky world whose iconic red color has earned it the nickname, the Red Planet. It is just a smidge more than half of Earth's size, with gravity only 38% that of Earth's. It takes longer than Earth to complete a full orbit around the Sun, but it rotates around its axis at roughly the same speed. That's why 1 year on Mars lasts for 687 Earth days, while a day on Mars is just 40 minutes longer than on Earth. Despite its smaller size, the planet's land area is also roughly equivalent to the surface area of Earth's continents, meaning that, at least in theory, Mars has the same amount of habitable real estate. Unfortunately, the planet is now wrapped in a thin carbon dioxide atmosphere and cannot support earthly life forms. Methane gas also periodically appears in the atmosphere of this desiccated world, and the soil contains compounds that would be toxic to life as we know it. Although water does exist on Mars, it's locked into the planet's icy polar caps and buried, perhaps in abundance, beneath the Martian surface. Today, when scientists scrutinize the Martian surface, they see features that are unquestionably the work of ancient flowing liquids. Branching streams, river valleys, basins, and deltas. Those observations suggest that the planet may have once had a vast ocean covering its northern hemisphere. Elsewhere, rainstorms soaked the landscape, lakes pooled, and rivers gushed, carving troughs into the terrain. It was also likely wrapped in a thick atmosphere capable of maintaining liquid water at Martian temperatures and pressures. Somewhere during Martian evolution, the planet went through a dramatic transformation, and a world that was once rather Earth-like became the dusty, dry husk we see today. The question now is, what happened? Where did those liquids go, and what happened to the Martian atmosphere? Exploring Mars helps scientists learn about momentous shifts in climate that can fundamentally alter planets. It also lets us look for biosignatures, signs that might reveal whether life was abundant in the planet's past, and if it still exists on Mars today. And the more we learn about Mars, the better equipped we'll be to try to make a living there, someday in the future. That's why the Red Planet has been a target for investigations over many centuries. No planet has been so heavily explored, other than our own. Starting in the late 1700s, British astronomer William Herschel made some early scientific observations of Mars with a telescope, and he noted that Mars had darker areas, which he believed to be oceans, and lighter regions, which he thought were continents like those on Earth. In the 19th century, Mars was investigated by Italian astronomer Giovanni Schiaparelli and American astronomer Percival Lowell, who believed they saw long canals on the planet's surface indicating civilizations and life. Their claims were dismissed by others in their time and ultimately turned out to be incorrect. The first attempts from both the US and the USSR to send probes to Mars during the space race ended in failure. The first probe to succeed was NASA's Mariner 4 probe, which reached the Red Planet on July 15, 1965, flying by it and sending back photos of the planet's surface. While the US managed a few more early triumphs, the Soviet Union's probes mainly failed. Historically, half of all the probes sent to Mars have crashed or died. NASA's Mariner 9 was the first mission to successfully orbit Mars, according to the agency. Reaching its target in 1971, Mariner 9 studied a large dust storm that engulfed most of the planet. The Viking 1 and 2 landers were the first human-made objects to make it to the red planet's surface and survive for more than a few minutes when they reached the Martian land in 1976. From the surface, they proceeded to take photos and data readings of their surroundings, as well as conduct the first search for life on the planet. Though there was a lull in missions afterward, space agencies around the world continued to make attempts at robotic exploration of Mars during the 1980s and 1990s. On July 4, 1997, NASA landed its first probe on Mars in 2 decades, the Pathfinder lander and its adorable tiny rover, Sojourner. These were followed by many orbiters and landers, including the twin rovers Opportunity and Spirit, which conducted investigations from 2004 to 2018 and 2019, respectively. The current suite of robots on Mars includes NASA's Curiosity and Perseverance rovers, both of which have produced incredible scientific findings during their missions. For instance, in a recent finding, NASA's Curiosity rover has detected something weird that no one can explain on Mars' surface. In a stunning revelation, Curiosity has discovered an abundance of pure sulfur on Mars after it recently drove over a rock and cracked it open, stunning scientists. The 6-wheeled rover has spotted sulfur on Mars before, but only in a mixture with other minerals, including magnesium and calcium. Pure sulfur, an odorless element that forms in very specific conditions that planetary scientists hadn't linked to the rover's location, appears to be infused in many rocks across the region. In the rover's photo of the rock, yellow sulfur crystals can be seen crowding within the inner regions of the object's crushed pockets. These crystals were too small and brittle for Curiosity to sample with a drill, so it ended up parking near another large rock nicknamed Mammoth Lakes. Here, the rover used a drill at the end of its robotic arm to scoop out a hole in that rock and stored it for further analysis before trawling away. Curiosity, which is currently in the 12th year of its mission, stumbled upon its latest discovery on May 30th when it was exploring Gediz Vallis, a channel winding down the slopes of Mount Sharp in the center of the Gale crater. The rover has been studying the channel for the past few months for signs of ancient microbial life. From what we understand of Mars' past, Mount Sharp would have been a lot wetter billions of years ago than it is today. The Gediz Vallis channel snaking through the mountain would have been carved as the planet began drying out, possibly by strong winds or even violent flows of liquid water. Curiosity has identified some signs of this history, particularly in mounds of debris scattered within the channel. The rocks sport pale rings or halos near their edges, which scientists say are caused by water-led chemical reactions after the rocks absorbed available minerals deposited in the area. Scientists aren't sure what role Mars's history would have in forming the pure sulfur just discovered, or if the element has any connection to other sulfur-based minerals previously discovered in the region. But discovering strange and unexpected things is what makes planetary exploration so exciting. What's notable is not only Curiosity, but Perseverance also came into the spotlight in the Conquer of Mars. Perseverance, nicknamed Percy, the centerpiece of NASA's $2.7 billion Mars 2020 mission, touched down inside the red planet's Jezero crater on February 2021. If Perseverance looks familiar, that's because the robotic explorer is largely based on its predecessor, the Mars Science Laboratory, MSL Curiosity rover, which landed in August 2012 and is still going strong today. Like Curiosity, the Perseverance rover was built by engineers and scientists at NASA's Jet Propulsion Laboratory in Pasadena, California. Roughly 85% of Perseverance's mass is based on Curiosity's heritage hardware, saving NASA time and money and reducing risk considerably. Perseverance is about 3 meters long, 2.7 meters wide, and 2.2 meters tall. At 1,025 kilograms, Perseverance weighs less than a compact car. Like Curiosity, Perseverance has a rectangular body, 6 wheels, a robotic arm, a drill for sampling rocks, cameras, and scientific instruments. But those instruments are quite different than the gear aboard Curiosity because the two rovers have divergent goals. Curiosity's main task involves assessing the habitability of ancient Mars, whereas Perseverance will hunt for evidence of ancient Martians. Perseverance's 7 instruments build on the success of MSL, which was a proving ground for new technology. These will gather science data in ways that weren't possible before. Notably, in the latest discovery, NASA's Perseverance rover may have found signs of ancient life in a rock on Mars, and that then caused a stir in the scientific community. The rover has come across an intriguing, arrowhead-shaped rock that hosts chemical signatures and structures that could have been formed by microbial life billions of years ago, when Mars was significantly wetter than it is today. Inside the rock, which scientists have nicknamed Chayava Falls, Perseverance's instruments detected organic compounds, which are precursors to the chemistry of life as we know it. Wisping through the length of the rock are veins of calcium sulfate, which are mineral deposits that suggest water, also essential for life, once ran through the rock. The rover also found dozens of millimeter-sized splotches, each surrounded by a black ring and mimicking the appearance of leopard spots. What's remarkable, these rings contain iron and phosphate, which are also seen on Earth as a result of microbe-led chemical reactions. That's why scientists said that these spots are a big deal. Chayava Falls sits at the edge of an ancient, 400-meter-wide river valley named Neretva Vallis. Scientists suspect this ancient channel was carved out long ago due to water gushing into Jezero crater. Neretva Vallis runs along the inner wall of this region. In one possible scenario, mud that already possessed organic compounds got dumped into the valley and later cemented into the Chayava Falls rock, which Perseverance sampled on July 21st. A second episode of water oozing into the formed rock would have created the object's calcium sulfate veins and black-ringed spots the team sees today. To be clear, the rock's visible features aren't irrefutable evidence of ancient microbial life on Mars. Not yet, at least. For instance, it is possible that the observed calcium sulfate entered the rock at uninhabitably high temperatures, perhaps during a nearby volcanic event. However, whether such non-biological chemical reactions could have resulted in the observed black-ringed spots is an open question. As Nicola Fox, the Associate Administrator of NASA's Science Mission Directorate, said in the statement, "This trip through the Neretva Vallis riverbed paid off as we found something we've never seen before, which will give our scientists so much to study." But while scientists on the Perseverance team are very excited about the rock, they stressed that they did not detect anything that could be fossilized organisms. It is also worth noting that the Perseverance rover isn't designed to detect and confirm alien life. It's collecting samples of scientific interest that will be returned to Earth for further scrutiny. Perhaps the Chayava Falls rock could one day address a question that has existed for as long as humans have looked skyward. Are we alone in the universe? The answer may very well land on Earth before the end of next decade if NASA's troubled Mars sample return program pans out and delivers those precious samples home, where scientists can scrutinize them with a greater variety and complexity of instruments than Perseverance can carry. However, the complex Mars sample return effort itself has run into many snags in recent months after its costs spiked to $11 billion. In its current form, the program requires multiple launches to Mars to place a vehicle on the red planet, after which either Perseverance will travel to the vehicle and drop off its collected samples, or pop those samples over to a retrieval helicopter that can complete the handoff. Then, an ascender would launch the samples into orbit, where a spacecraft would collect them and return them to Earth. NASA assessed various simpler alternatives from industry and academic groups and awarded $1.5 million contracts to 7 companies looking into the endeavor. 3 of the agency's own research centers are carrying out studies as well. If all goes well, sending people to the red planet will on humanity's next to-do list. But it's no secret the obstacles are daunting. The fact that no person has traveled beyond low Earth orbit since the Apollo program ended in 1972 highlights the reality that long-duration, long-distance missions with fragile humans on board are fraught with intimidating challenges. What are some of the biggest concerns? Dinah Isa, director of the Mars Campaign Office within NASA's Exploration Systems Development Mission Directorate, sees many of the challenges as similar to those faced by the Apollo program, such as creating powerful and versatile spacecraft with robust life support systems to keep astronauts alive. But the one issue she sees as most troublesome, one that can't really be fixed, is the time delay for communications between Earth and Mars. The distance between Earth and the Moon enables us to have conversations, work on problems, and anomaly resolution in practically real time. Because of Mars's distance, it's a much bigger delay between 4 and 24 minutes one way, so it could take over 40 minutes round trip for someone to ask a question and then get a reply. Even more worrisome are the periods of solar conjunction every 26 months, when the Sun is between Earth and Mars. This creates a 2-week communications blackout, because radio signals can't pass through the Sun, and charged solar particles in the vicinity distort signals that pass too close. If any emergency or issues with critical life support systems arose during that time, the crew would be on their own to solve the problems. Thus, NASA now is looking into developing a relay system of communication satellites placed in other locations in the solar system, which could cut down the 2-week blackout to just a few hours. Laser communications, a technology currently being tested on the Psyche spacecraft, would allow for more data per second with superior signal fidelity. But still, the delay time in communications means increased risk for any operations on Mars. Additionally, research indicates communication lags are psychologically difficult and can lead to feelings of isolation and negatively affect cognition and performance. Beside the time delay for communications, the lack of a global magnetic field on Mars, along with the planet's thin atmosphere, means high-energy cosmic rays and solar particles shower the Martian surface. These high doses of radiation and the associated health risks could be a showstopper for human activity on the red planet and for the trip there and back. Physical shielding with heavy materials would work, but the high price of launching hefty shields isn't ideal or cost-effective. Scientists have dreamed of creating force fields that could create a protective bubble around a spacecraft or habitat. However, research indicates these fields would take a prohibitive amount of power and structural material to create on a large scale, so more work is needed for them to be feasible. However, a material called hydrogenated boron nitride nanotubes, BNNTs, could be a game-changer. The material includes carbon and nitrogen, which can shield against radiation, and boron is an excellent absorber of secondary neutrons. These nanotubes are small and flexible enough even to be woven into the fabric of spacesuits. While still in development and testing, BNNTs have the potential to become a key structural and shielding material for spacecraft, habitats, vehicles, and clothing used on Mars. In addition, rather than bringing large quantities of oxygen to Mars, future astronauts could live off the land, using materials they find on the planet's surface to survive. This concept, called in situ resource utilization, has now been proven by an instrument on the Perseverance rover. MOXIE, for Mars oxygen. In situ resource utilization experiment extracted oxygen from Mars's thin atmosphere and was able to produce 12 grams of oxygen an hour, twice as much as the original goal for the instrument. Not only could a larger MOXIE-like system supply breathable air, but it could also help create rocket propellant, which will be required in massive quantities to launch rockets with astronauts for their return trip home. Michael Hecht, the instrument's principal investigator from the Massachusetts Institute of Technology, said he and his team would be ready to scale up the system if funding was available. But before astronauts can leave the surface of Mars, they must first get there. The biggest challenge in exploring Mars might be slowing down a large, human-sized spacecraft from speeds of tens of thousands of kilometers per hour to enable a touchdown gentle enough for astronauts and payloads to survive. So far, landers and rovers have used parachutes, airbags, or sky cranes to safely land on the red planet. But these technologies have likely reached their limits. The Perseverance rover, currently the largest rover or lander sent to Mars, has a mass of about 1 metric ton. But a human mission to Mars will likely require a vehicle between 50–100 metric tons, depending on the configuration. These larger vehicles will be too heavy to be slowed significantly by aerodynamic drag in Mars' thin atmosphere, which has less than 1% the density of Earth's. But the outlook for slowing incoming vehicles has improved compared to a decade ago. NASA's low Earth orbit flight test of an inflatable decelerator known as LOFT-ID took place in 2022, successfully inflating a 6-meter diameter aerodynamic decelerator system in Earth's stratosphere, which has a density similar to Mars's atmosphere. This quickly inflating aeroshell creates more drag in the upper atmosphere to help the spacecraft slow down sooner, which also prevents some of the super intense heating. Additionally, engineers now are optimistic about using thrusters for what is called supersonic retropulsion. Previously, aerodynamic experts were uncertain that the thrust from rocket motors pointed in the direction of travel to decelerate could be done successfully while traveling through an atmosphere at supersonic speeds. But now, enter SpaceX's desire to reuse the first stages of their Falcon 9 rockets by having them use retro rockets to return to Earth. There's a portion of the flight where they fire their engines backwards at supersonic speeds through a rarefied atmosphere, which is very much like what's at Mars. We asked if we could watch and study their data to learn more about it. To our surprise and delight, we learned some new physics. The shock front bubble created around the vehicle from firing the engines somehow insulates the spacecraft from any buffeting as well as from some of the heating. While several technical issues still need to be resolved, Manning is optimistic they can be worked out for future human exploration of Mars. So, despite numerous obstacles, Mars remains an ideal destination. NASA is starting to explore different ways to undertake space missions. For decades, NASA and other space agencies around the world have spent large sums on in-house planning, development, prototyping, and production for space missions. In the 2020s, the technologies that enable and support space exploration are increasingly being developed in the commercial world. An example most people will be familiar with is Elon Musk's SpaceX. Many of the SpaceX objectives have Mars and beyond as the ultimate goal, making humanity interplanetary. The development of the Falcon rockets by SpaceX, Starlink satellites, and the Starship rocket could not be further from NASA's historical model. Where the NASA approach has been conservative, SpaceX makes lots of changes fast, iterates quickly, and learns quickly from failure. The SpaceX Starship rocket development. And SpaceX is not alone. There is a growing industry of commercial providers of access to space, particularly in the United States. NASA's current roadmap involves going back to the Moon to re-establish a human presence with the Artemis program, then on to a human presence on Mars. In this roadmap, the concept of leveraging commercial providers has taken hold. Instead of in-house development, NASA is moving in favor of specifying requirements and then assessing the solutions commercial providers might supply in a competitive process. It appears that now, even compared to 20 years ago, such an approach has become much more viable, as demonstrated by SpaceX. In theory, it could be cheaper and more efficient. Likely the bigger positive effect will be the substantial stimulus to the commercial sector. With companies innovating to meet the requirements of space missions, the technology spin-offs will potentially have more economic and social impact than getting to Mars itself. There is a good history of this from the development of technologies for space and from mega science projects more generally. However, it is very early days and the commercial approach has to prove itself. There is always an argument that once you start to cease in-house development at a place like NASA, capabilities start to gradually decay. Time will tell. The first steps, reaching the moon, will go a long way in testing the approach. Regardless, there are some pieces of good news. Until recently, it seemed as if the US and SpaceX were set to win this race to return to the moon with NASA's Artemis program. But a number of setbacks have called that into question, and Blue Origin, China, and other countries and companies are continuing their own lunar efforts. On January 9, 2024, NASA announced that it was delaying the Artemis II mission, the first crewed flight of the Space Launch System, or SLS, and the Orion capsule, the vehicles built to send astronauts back to deep space. The flight would slip from late 2024 to no earlier than September 2025. This was due to some safety issues that need to be fixed on Orion. Consequently, Artemis III, which is supposed to involve the first crewed lunar landing since 1972, will take place no earlier than September 2026. Artemis III is to use SpaceX's Starship orbiter as the lander for 2 crew members. This mission is set to put the first woman and the first person of color on the lunar surface. A non-American crew member could also walk on the moon by 2030, highlighting the fact that NASA has involved international partners in the Artemis venture. Up until now, just 12 humans have set foot on the moon. All of them have been male and all have been American. However, the Starship orbiter, crucial to these aims, has experienced problems. A second test launch for the rocket ship-like orbiter atop its huge booster rocket back in November 2023 was spectacularly destroyed 8 minutes and 6 seconds after liftoff. It will have to be ready to go by 2026. But before then, SpaceX will have to demonstrate that it can refuel in orbit and then land Starship on the moon without crew. However, at the same time, Blue Origin is also working on a lander called Blue Moon. Blue Moon is due to be used as the moon landing craft for the Artemis 5 and 6 missions in 2029 and 2030. Time will tell which lander can actually be ready for use first. But competition is always a good stimulator, and it could accelerate achievements. Commercial companies supporting NASA in the Artemis program will have to put a lot of attention into what to do and when. The lives of crew members are at stake here, so missions have to proceed in a safe and sustainable manner. As with Apollo, NASA is also trying to use the program to inspire the next generation of scientists, engineers, and mathematicians. Baby boomers like myself are very proud to be Apollo kids who were inspired to study scientific subjects by those momentous achievements, particularly the first steps on another world viewed through black and white TVs in July 1969. China is also preparing itself, together with several other countries, including Russia, to develop a lunar base for humans, called the International Lunar Research Station. Beijing and its partners will include also private sector's players and governmental and non-governmental organizations, with an organizational scheme which is a first. The Chinese program's first human missions to the lunar surface are expected by 2030. Among the sites where they want to land is the moon's south pole. NASA also wants to land here, but but few of Beijing's choices are in overlap with the locations selected for Artemis. The South Pole is a target for both the US and China because countries want to extract the water ice that's hidden in craters there. This water could be used for life support at lunar bases and to make rocket fuel, helping bring down the cost of space exploration. Space programs are never on time, and postponements are normal. Space agencies are more cautious nowadays, even more than before, because few tragedies we experienced in the past are obliging them to think very carefully before launching humans in space. Safety of the crew is mandatory, and it must be always the first priority. So, if this is the reason why we have to wait a bit more before few human beings, after decades, will walk again on the moon, I'm happy to wait for it. Going to space has never been easy, as demonstrated by several uncrewed missions to the moon over the last 12 months, both governmental and commercial, which didn't make it. But perhaps it's better we fail now while we are preparing for the new phase of humanity's history. The moon will soon experience human beings on its surface again, working and living on a regular basis. But when humans go back there, this time it will be to stay. After conquering the moon, the Mars is next target. But how long does it take to get to Mars? If you could jump in a car and travel at 161 kilometers per hour, it would take about 14,283 days or 40 years to reach Mars. But if you wanted some exercise, you could walk at 6 kilometers per hour and get there in 1,065 years. Earth and Mars travel around the Sun at different speeds and distances, so the distance between us varies considerably. To put things into perspective, it would take 3,536 years to travel to the Sun by walking. But a day on Mars is remarkably similar to a day on Earth, and that's largely because, relative to the rest of the solar system, the distance from Earth to the Sun is similar to the distance between Mars and the Sun. At the furthest distance, Earth and Mars are on opposite sides of the Sun, called a solar conjunction, when we are about 401 million kilometers apart. The average distance between Earth and Mars is 225 million kilometers. The two planets are closest when we are both on the same side of the Sun, called opposition, at about 56 million kilometers apart. This happens every 2 years and is our launch window to the Red Planet. The first successful mission to Mars, Viking 1, launched on 20th August 1975 and landed on 19th June 1976, 10 months later. The rover's Spirit and Opportunity took just 6 months to reach Mars, in 2003 and 2004. The Curiosity rover launched on 26 November 2011 and landed on Mars on 5 August 2012. Perseverance rover launched on 30th July 2020 and landed on Mars on 18th February 2021. Various space agencies are working towards a crewed mission to the Red Planet. NASA is working towards a 9-month journey, while SpaceX hopes to cut the trip to 6 months. The time it takes to get from Earth to the Red Planet is mainly dependent on the propulsion method used. A photon propulsion system is currently in development that would use a powerful laser to accelerate spacecraft to near the speed of light, cutting the journey to just 3 days. That sounds great, but it's hard. Very hard. And if luckily we truly land on the Red Planet, the problems remain. Either way, setting up and surviving at a Mars colony would be even more complicated. Since astronauts can't haul construction materials from Earth, scientists are dreaming up ways for astronauts to use materials on Mars. Long-term visitors would also need plenty of oxygen to breathe. A device on NASA's Perseverance rover is currently laying the groundwork for a future Mars oxygen factory. The device pries oxygen off molecules of carbon dioxide, the main gas in Mars's atmosphere. In addition, it's worth noting that planning for a trip to Mars isn't just about protecting astronauts. It's also about protecting Mars from astronauts. Humans are teeming with microbes, and spreading those microbes could compromise the search for life on Mars. As a result, a key part of responsible space exploration is making sure Earth germs don't infect other planets. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time. Dark. Of course, we now know that the moon orbits Earth, and they both orbit the sun. The dark side is merely a trick of perspective. The Apollo astronauts who went to the moon saw the other side and actually basked in the sunlight there. As it turns out, different parts of the moon are sunlit during different parts of each month, and not just one side. Its shape seems to change, which is what we call the phases of the moon. Interestingly, new moon, which is the time when the sun and moon are on the same side of Earth, is when the face we see from Earth actually is dark and the far side is brightly lit by the sun. So, calling the part that faces away from us as the dark side really is a mistake. So, what do we call that part of the moon we don't see each month? The better term to use is the far side. It makes perfect sense since it is the side farthest away from us. To understand, let's look more closely at its relationship to Earth. The moon orbits in such a way that one rotation takes just about the same length of time as it takes for it to orbit around Earth. That is, the moon spins on its own axis once during its orbit around our planet. That leaves one side is facing us during its orbit. The technical name for this spin-orbit lock is tidal locking. Of course, there is literally a dark side of the moon, but it's not always the same side. What is darkened depends on which phase of the moon we see. During a new moon, the moon lies between Earth and the sun. So, the side we normally see from here on Earth that's normally lit by the sun is in its shadow. Only when the moon is opposite from the sun do we see that part of the surface lit up. At that point, the far side is shadowed and is truly dark. The far side of the moon was once mysterious and hidden, but that all changed when the first images of its cratered surface were sent back by the USSR's Luna 3 mission in 1959. It's been more than 60 years since those first photos were returned to Earth. By current standards, they're rather poor images, but they were good enough to tell us that the far side of the moon was nothing like the near side. We got another stack of images of the lunar far side shortly afterwards, during the Apollo era, which was a product of a space race, which had been going on between the US and the Soviet Union. The two Cold War rivals were both determined to outdo the other and land humans on the lunar surface first. The US efforts in this contest included two predecessors to Project Apollo, Project Mercury, which began in 1958, and Project Gemini, which followed in 1961. But until the moon landing itself, the Soviet space program was ahead overall, with successful missions, including Sputnik, the first satellite to orbit Earth, and Luna 2, the first space probe to touch the moon. So, in 1961, President John F. Kennedy decided to take charge and propose to Congress the goal of landing a man on the moon and returning him safely to the Earth by the end of the decade. This seemingly impossible task quickly became the ultimate goal of the Apollo program, also known as Project Apollo. Kennedy's famous speech at Rice Stadium the next year inspired Americans to dream big. The announcement lit a fire under the teams at NASA to complete the task on a seemingly impossible timeline. But the ambitious goal required an equally ambitious budget. The US government ended up allocating $25 billion in 1960s dollars to the Apollo program, or about 2.5% of the US GDP at the time annually, for approximately 10 years. As such, the Apollo program, by far the most expensive spaceflight endeavor in history, kicked off that year, and by the time it ended in 1972, 9 missions and 24 astronauts had orbited or landed on the moon. Perhaps the most famous of those, Apollo 11, marked the first time humans had stepped on another world. On July 20th, 1969, Neil Armstrong and Edwin Buzz Aldrin touched down in the Sea of Tranquility in the lunar lander Eagle, while astronaut Michael Collins orbited the Moon in the command module Columbia. Armstrong, who pressed the first boot prints into the Moon's surface, famously said, "That's one small step for a man, one giant leap for mankind." The pair stayed on the Moon's surface for 21 hours and 36 minutes before rendezvousing with Collins and heading back to Earth. Each mission after Apollo 11 set new milestones in space travel and lunar exploration. 4 months after the first humans reached the Moon, Apollo 12 touched down, achieving a much more precise landing on the Moon. Apollo 13 narrowly avoided a near disaster when onboard oxygen tanks exploded in April 1970, forcing the crew to abort a planned Moon landing. All 3 survived. During the third lunar landing in January 1971, Apollo 14, Commander Alan Shepard set a new record for the farthest distance traveled on the Moon, 9,000 feet. He even lobbed a few golf balls into a nearby crater with a makeshift 6-iron. Apollo 15, launched in July 1971, was the first of 3 missions capable of a longer stay on the Moon. In the course of 3 days spent on the lunar surface, achievements included collecting hundreds of pounds of lunar samples and traveling more than 17 miles in the first piloted moon buggy. Apollo 16 and Apollo 17 in 1972 were the 2 most recent crewed missions to the Moon, and Russia's Luna 24 crewless spacecraft in 1976 was the last to land until the following century. Samples collected during these lunar explorations produced huge amounts of knowledge about the geology and formation of the Earth's moon. After the dramatic accomplishments of the 1960s and 1970s, the major space agencies turned their attention elsewhere for several decades. So far, only 12 humans have set foot on the Moon. However, during each Apollo missions, astronauts experienced strange phenomena that heightened the intrigue surrounding the Moon. For instance, in Apollo 11 mission, on July 21, 1969, while Neil Armstrong and Buzz Aldrin made history by stepping onto the lunar surface, Michael Collins orbited alone in the command module. As Collins traveled behind the Moon, he entered a period of complete isolation, cut off from all communication with Earth. During these 47 minutes, he reported hearing eerie, unexplained sounds through his headset. These sounds were unsettling and unlike anything encountered before. This was not an isolated incident. The Apollo 10 mission, which served as a dress rehearsal for the Moon landing, also reported hearing similar mysterious sounds on the far side of the Moon. NASA later attributed these noises to radio interference, but many astronauts were unconvinced by this explanation. The sounds, described as whistling space music, added to the growing list of peculiarities and raised further questions about the true nature of the Moon. The astronauts' accounts fueled public speculation and conspiracy theories about what they might have encountered. Some believed these sounds indicated intelligent life or advanced technology on the Moon. Despite NASA's attempts to explain away these anomalies, the eerie experiences of the Apollo astronauts continued to captivate imaginations and spark debates about what really lies on the Moon's far side. A significant element fueling the mystery around the Moon is the missing tapes and transcripts from the Apollo missions. While the world watched the Moon landings in awe, crucial minutes of radio communication between the astronauts and NASA's mission control mysteriously vanished. These missing segments have led to rampant speculation about what might have been captured during those lost moments. According to unofficial transcripts, during these gaps, astronauts reported seeing strange objects and even claimed that they were being watched by unidentified entities. One notable incident involves Neil Armstrong and Buzz Aldrin, who allegedly saw UFOs lined up on the crater's edge. This startling claim, if true, would have been groundbreaking evidence of extraterrestrial presence on the Moon. However, without the original recordings, it's challenging to verify these assertions. NASA has maintained that the tapes were either misplaced or recorded over, a convenient explanation that has done little to quell conspiracy theories. The idea of deliberate censorship by NASA gained traction when whistleblowers claimed that the space agency intentionally suppressed and sanitized evidence of extraterrestrial activity. The absence of these tapes has only deepened suspicions and has become a cornerstone for those convinced that the moon holds secrets far beyond human understanding. This controversy has kept the public questioning the true nature of the Apollo missions and what might have been discovered and hidden during humanity's first steps on the lunar surface. The mystery of the moon deepens with reports of UFO sightings by astronauts and the use of code words to describe these encounters. During the Apollo missions, astronauts often reported seeing unidentified flying objects, which they referred to using code names like bogey, Santa Claus, and fire. These terms were meant to keep their observations discreet, away from the public and media scrutiny. One of the earliest recorded UFO sightings in space came from Gemini 4 astronaut James McDivitt in 1965. He described seeing a strange object with arms protruding from it. But before he could capture a clear photograph, the sun's glare obstructed his view. This incident led NASA astronauts to develop code words to discuss such sightings without alarming the public or drawing undue attention. The Apollo 8 mission, which orbited the moon in 1968, is famously noted for its Christmas Eve broadcast, during which astronaut Jim Lovell reported seeing a Santa Claus, a veiled reference to a UFO. While NASA brushed off this comment as a joke, it fed into the growing speculation and conspiracy theories surrounding the moon missions. These sightings and the coded language used by astronauts suggest that there were more unexplained phenomena encountered during the lunar missions than what was publicly acknowledged. The consistent use of these codes indicates that such sightings were not isolated incidents, but a recognized and somewhat common occurrence among astronauts. This has left many to wonder what other secrets and anomalies were observed but never disclosed, further entrenching the belief in a covert extraterrestrial presence on or around the moon. The testimonies of whistleblowers have added a dramatic layer to the mystery of the moon, bringing claims of secret moon bases and alien structures into the spotlight. Among the most prominent whistleblowers is Sergeant Carl Wolf, who worked at NASA's Lunar Orbiter project in 1965. Wolf claimed that he was shown photographs of structures on the far side of the moon, including towers, spherical buildings, and mushroom-shaped constructs. According to Wolf, these images clearly depicted artificial creations, suggesting the presence of an advanced civilization on the moon. Another key figure is Dr. Ken Johnston, a former NASA aerospace engineer who worked in the Lunar Receiving Laboratory during the Apollo missions. Johnston claimed to have seen photographs of ancient alien cities and machinery on the lunar surface. When asked to destroy these images, he instead kept a set, which he later revealed to the public. His disclosures, however, led to his dismissal from NASA and cast him into the realm of conspiracy theories. Donna Hare, another NASA contractor, supported these claims, stating that NASA routinely airbrushed out UFOs and other anomalies from lunar photographs before releasing them to the public. She recounted an incident where a technician pointed out a round shadow on a photo, indicating a UFO had been deliberately erased from the image. These whistleblowers faced significant professional and personal risks by coming forward. Their stories have been met with skepticism and scrutiny, but they continue to resonate with those who believe in extraterrestrial activity on the moon. The allegations of a cover-up, combined with these dramatic accounts, suggest that the moon harbors more secrets than the public has been allowed to know, perpetuating the allure and enigma of lunar exploration. The deaths of whistleblowers have further fueled suspicions of a cover-up regarding lunar anomalies and extraterrestrial activities. Sergeant Carl Wolf's tragic end came in 2018 when he was hit by a truck while cycling, a death that many conspiracy theorists find suspicious, given his revelations about secret moon bases. Wolf had boldly stated his willingness to testify before Congress under oath about what he had seen, but his untimely death prevented him from doing so, leaving his claims shrouded in mystery. Dr. Ken Johnston also faced significant backlash after revealing photographs of alien structures on the moon. Despite his dismissal from NASA, he continued to advocate for transparency about what he believed were clear signs of extraterrestrial presence on the lunar surface. Although he didn't face a mysterious death like Wolf, his professional reputation was significantly tarnished, and he became a marginalized figure within the scientific community. These whistleblowers were not alone. Donna Hare, who claimed NASA airbrushed UFOs from lunar photographs, also faced intense scrutiny and skepticism. Her assertions about sanitized images highlighted the lengths to which she believed NASA would go to hide evidence of extraterrestrial encounters. Despite the lack of physical evidence, her testimony contributed to the narrative of a deliberate cover-up. The deaths and discrediting of these whistleblowers underscore the risks faced by those challenging official narratives. Their accounts, whether wholly accurate or not, have added layers of intrigue and suspicion to the story of lunar exploration. Many believe that these individuals were silenced or discredited to prevent the truth from coming out, perpetuating the idea that there are significant, undisclosed mysteries about the moon that authorities are determined to keep hidden. Today, modern lunar anomalies continue to intrigue and fuel speculation about what might be hidden on the moon's surface. With advancements in technology and renewed interest in lunar exploration, numerous images and reports have emerged showing strange, unexplained features. One of the most notable cases is the 1994 Clementine orbiter mission, which took millions of images of the moon. Upon release, many of these images appeared to have sections blurred out, suggesting deliberate censorship. The so-called Zan object in the Zonde crater is a prime example, where overlapping and enhancing images revealed what seemed to be a large, possibly artificial structure. Other anomalies include what look like giant footprints, pyramids, obelisks, and mile-high towers scattered across the lunar surface. Scientists have attempted to explain these features as natural formations, such as meteor impacts, but the uniformity and scale of some of these structures challenge these explanations. For instance, the Mystery Hut, photographed by China's Yutu-2 rover in 2021, sparked a global buzz, though it was later identified as a rock formation. Moreover, images from various lunar missions show peculiar shapes and alignments that don't fit natural patterns, such as the uniformly deep craters and geometric structures. The blurred-out sections and anomalies have led to widespread speculation about what might be hidden. Some believe these features could be remnants of ancient alien civilizations or even operational extraterrestrial bases. NASA's explanations, often attributing these phenomena to tricks of light or pareidolia, the human tendency to see familiar shapes in random patterns, haven't satisfied everyone. The deliberate blurring of images, coupled with historical claims of whistleblowers, keeps the intrigue alive. As more countries and private companies prepare for lunar missions, there is hope that new explorations will provide clearer answers. Until then, the moon remains a focal point of mystery, with many convinced that its secrets are waiting to be uncovered. The renewed interest in lunar exploration marks a new era of discovery and potential revelation of the moon's secrets. After a long hiatus since the Apollo missions, numerous countries and private companies are setting their sights on the moon. This renewed effort is driven by advancements in technology, a desire for scientific knowledge, and potential economic opportunities. In recent years, China has made significant strides with its Chang'e missions. In 2020, the Chang'e 5 mission successfully brought back samples from the moon, while the Yutu-2 rover continues to explore the moon's far side, capturing intriguing images, including the Mystery Hut. The United States, through NASA's Artemis program, plans to return astronauts to the lunar surface by 2026, aiming to establish a sustainable human presence and explore the lunar South Pole. These missions aim to uncover new scientific data and test technologies for future Mars missions. India's Chandrayaan-2, Russia's Luna 25, and Japan's SLIM mission are also part of this renewed interest. Additionally, private companies like SpaceX, Blue Origin, and Firefly are developing their lunar missions, with goals ranging from lunar tourism to mining resources. This resurgence in lunar exploration is not just about national pride or scientific curiosity. There is a growing belief that the moon holds valuable resources, such as helium-3, which could be used for future energy production. Furthermore, establishing a presence on the moon is seen as a stepping stone for deeper space exploration, including missions to Mars. As these missions progress, there is hope that they will also address some of the long-standing mysteries and anomalies that have fueled conspiracy theories for decades. The influx of new data and images from diverse sources may either confirm or debunk the theories of alien structures and hidden bases on the moon. With multiple players involved, the next decade promises to be a period of unprecedented lunar activity, potentially unraveling the secrets that have long eluded us, and possibly confirming whether the moon is just a barren satellite or a repository of extraordinary discoveries. In addition, note that the potential science from future lunar mission stretches far beyond the moon. Scientists believe that a new radio telescope on the far side of the moon could capitalize on NASA's new Artemis era of lunar exploration to potentially probe deeper into the universe than even the newly operational James Webb Space Telescope can. A proposal for a lunar telescope named Farside, led by Jack Burns of the University of Colorado Boulder, was submitted as a potential probe-class mission costing $1 billion to $2 billion. Burns has been working on a plan for a radio telescope on the moon since the 1980s, but ultimately Farside wasn't selected for recommendation by the Decadal Survey. However, a brand new concept is now being evaluated called the Lunar Crater Radio Telescope, which is led by robotics technologist Saptarshi Bandyopadhyay of NASA's Jet Propulsion Laboratory in California. It would be a 350-meter diameter radio telescope in a 1.3-kilometer wide crater on the far side of the moon. The original plan was for an even larger telescope, 1 kilometer in size, but the sheer scale of that instrument proved unfeasible because of the total mass that would need to be launched from Earth. Fortunately, as we looked at the science, we realized that a diameter of 350 meters would be sufficient to give us the science that we want to get. That science involves seeing back in time to a distant era known as the Epoch of Ryanization. Shortly after the Big Bang, there were no stars and galaxies, only a vast fog of neutral hydrogen. This period has been dubbed the Cosmic Dark Ages. Eventually, the hydrogen began coalescing to form stars and galaxies, lighting up the universe and ionizing the neutral hydrogen. It is this early era that the Lunar Crater Radio Telescope would hope to see. Ordinarily, neutral hydrogen emits radio waves at a wavelength of 21 centimeters, but cosmic expansion will have lengthened the wavelength of the radio waves emitted by hydrogen in the Dark Ages to extremely long wavelengths of tens of meters. Detecting this long wavelength light on Earth is difficult, partly because the ionosphere, the upper realm of our atmosphere, can reflect light of these wavelengths back into space, and partly because terrestrial radio interference can obscure it. The thing to do would be to build a giant radio telescope on the far side of the moon where there is no ionosphere, and where the moon itself can shield the telescope from interference from Earth. Bandyopadhyay's plan is to send a spacecraft to a suitable crater on the lunar far side. The spacecraft would land inside the crater and then fire multiple cables with anchors into the rim of the crater, where the anchors would penetrate securely into the lunar regolith. The cables would then pull tight, creating a framework to hold the wire mesh radio dish, which would be folded like origami into the lander and open as the cables pull taut. A feed antenna would be deployed above the dish, and a spacecraft overhead would first provide a beacon signal to help calibrate the telescope, and then act as a relay for data and commands, since Earth cannot be seen from the lunar far side, hidden as it is behind the body of the moon. At least that's the plan. The Lunar Crater Radio Telescope is currently in Phase 2 of NASA's Innovative Advanced Concepts Development Program, through which it has received $500,000 of funding for maturing the necessary technology. But that's a far cry from the multi-billion-dollar budget that would be required to make the telescope mission a success. Because of the hefty price tag, the telescope requires strong support from the scientific community to win a recommendation in the next decadal survey. Fortunately, there may be another option, suggested Stephen Kahn, a physicist at Stanford University in California who is not directly involved with the project, in that it dovetails with NASA's desire to do more exploration on the moon. There are programmatic reasons to want to do more frequent flights to the moon, and so the hope is to try and capitalize on that, he said. This approach is embodied in NASA's Commercial Lunar Payload Services program, which will see more than 50 small science payloads be delivered to the moon by private contractors over the next 3 years. 3 of these payloads will head to the 312-kilometer-wide Schrödinger crater, which is an impact basin on the far side of the moon near the lunar South Pole, in 2025 on a lunar lander built by the Massachusetts-based aerospace company Draper. Schrödinger is an interesting target and is thought to be the second youngest impact basin on the moon. The 3 payloads, named the Farside Seismic Suite, or FSS, the Lunar Interior Temperature and Materials Suite, or LITMS, and the Lunar Surface. Electromagnetics Experiment, or LUCI, will investigate the relationship between the formation and size of the crater, as well as the interior structure of the moon. According to Needham, the impact that formed Schrödinger was so large that we think it penetrated all the way through the moon's upper crust and into the mantle. Exploring that will be really important in helping us understand the bulk chemistry of the moon, what the moon is made from inside and out, and how that helps us understand how the moon formed and how it cooled off from its hottest, earliest days when it was volcanically active and a much more dynamic place than it is today. For example, the seismometers will listen for moonquakes caused by meteorite impacts or by the strain on the moon's interior, caused by gravitational tides emanating from Earth. As the seismic tremors reverberate through the moon's interior, the signal that FSS will detect can tell scientists about the structure, composition, and density of the moon's interior. Meanwhile, the LITMS experiment is armed with a heat flow probe with which it will be able to take the internal temperature of the moon for further details about the interior of the moon. The final experiment, LUCI, will study dust in the moon's exosphere, which is the thin layer of gas and dust that clings close to the surface and is sputtered off the ground by micrometeorite impacts and electrostatic forces. Together, this trio of small robotic experiments could pave the way for further exploration of the far side.
Okay, Retro, go. Fido, go. Guide, go. Control, go. Telcom, go. GNC, go. Econ.
While the moon has always been an object of wonder and scientific interest to humanity, lunar exploration began in earnest in the 1950s, with the United States and the USSR developing and launching robotic spacecraft. In 1959, the USSR's Luna 1 was the first spacecraft to fly by the moon. In 1966, Luna 9 achieved the first soft landing, and in 1969, the US's Apollo 11 achieved the first human landing. In the decades since, many nations have contributed to lunar orbiters and landers. As of January 2024, 5 nations have successfully landed on the moon. But despite the incredible achievements, there was one aspect of the moon that remained out of reach: the far side. The far side of the moon has a certain mystique about it. It's eternally out of view, never facing the Earth, which has earned it a misleading nickname, the dark side, as if sunlight never reaches its surface. It's the section of the moon we'll never see for ourselves, not unless we hop on a spaceship and fly over there. But now, thanks to the James Webb Space Telescope, we can finally see what lies beyond the horizon, unlocking a new era of lunar exploration and discovery. Join us as we explore the mysterious realm of the moon's dark side, uncovering obscure details and highlighting our celestial neighbor's lesser-known features. Some people see a face in the moon, others see a rabbit or a toad. But regardless of what you see on the lunar surface, we all view the same side of our natural satellite. So, why don't we ever see the far side of the moon? To know why, let's look more closely at its relationship to Earth. The moon orbits in such a way that one rotation takes just about the same length of time as it takes for it to orbit around Earth. That is, the moon spins on its own axis once during its orbit around our planet. That leaves one side facing us during its orbit. The technical name for this spin-orbit lock is tidal locking. Of course, there is literally a dark side of the moon, but it's not always the same side. What is darkened depends on which phase of the moon we see. During a new moon, the moon lies between Earth and the sun. So the side we normally see from here on Earth that's normally lit by the sun is in its shadow. Only when the moon is opposite from the sun do we see that part of the surface lit up. At that point, the far side is shadowed and is truly dark. The far side of the moon was once mysterious and hidden. But that all changed when our first glimpse of the mysterious far side came early in the space race, courtesy of the Soviet Union's Luna 3 spacecraft almost 60 years ago. In 1959, barely 2 years after placing Sputnik 1 in orbit, Russian engineers managed to send the spacecraft, which was crude by today's standards, into orbit around the moon, and for the first time, we got a good look at the mysterious far side. Luna 3 took 29 film images of the far side in total, which were photographically developed, fixed, and dried on board. Remember, this was long before multi-megapixel cameras. Ironically, the film used had been stolen from American spy balloons, as it had to be sturdy and radiation-hardened. The spacecraft, using a combination of 2 camera systems, one wide field and one narrow field but higher resolution, and a crude onboard scanner, could then transmit the processed images, which were spot-scanned from the photographs, back to the receiving station in the former Soviet Union. Although only 17 of the 29 taken were transmitted successfully back to Earth, of which 6 were considered good enough for publication, they proved to be a revelation. Those 6 images covered 70% of the far side and opened a whole new perspective on the lunar surface. It was almost immediately evident that the dark patches that make the face of the man in the moon on the near side are almost completely absent on the far side. These dark patches are basaltic plains called mare, created by volcanic activity on the moon billions of years ago. Instead, the far side was littered with craters, even more so than the near side, and some of those craters were the size of small countries. The Soviets started naming many of the features they were seeing for the first time, an act which caused some controversy in what was known as the height of the Cold War era. We already had an inkling of one of those vast new craters, which is actually one of the very few mare on the far side. The subtlest hint of Mare Orientale, one of the largest impact craters known, seen on the limb of the moon, had been known of since its discovery by Julius Franz in 1906, and can be seen during good librations when that portion of the moon swings around towards us. The view from Luna 3 showed how vast an impact crater Orientale was, resembling a bullseye. It was almost 900 kilometers across, pretty much the length of the United Kingdom, give or take, and was caused by an asteroid impact, thought to be around 64-kilometer wide just under 4 billion years ago. The resulting giant crater, termed an impact basin, was subsequently filled with volcanic lava. In 1965, another Soviet mission, Zond 3, flew by the moon with a far better camera than Luna 3 possessed, and with the ability to conduct more detailed science observations, including spectroscopy. Zond 3 produced 23 very detailed photographs of the lunar far side, which enabled one of the first detailed maps of the entire lunar surface to be constructed. In the meantime, NASA was progressing its Apollo program at a phenomenal rate. Following the declaration by President Kennedy that the U.S. would place a man on the moon and return him safely to the Earth by the end of the 1960s, by December 1968, NASA was ready to send 3 people, including Frank Borman, Jim Lovell, and Bill Anders, all the way around the moon and back for the Apollo 8 mission. They became the first humans in history not only to escape from low Earth orbit, but also to see the elusive far side. This is how Lovell famously described the lunar surface. The moon is essentially gray, no color, looks like plaster of Paris or sort of a grayish beach sand. We can see quite a bit of detail. There's not as much contrast between that and the surrounding craters. The craters are all rounded off. There's quite a few of them. Some of them are newer. Many of them look like, especially the round ones, look like they were hit by meteorites or projectiles of some sort. When the Apollo 8 spacecraft flew around the far side of the moon, the signal to Earth was cut off for around 10 minutes. This loss of signal was a daunting time for the flight crew and mission control. Apollo 8 was alone and truly cut off from Earth, venturing where no human had ever gone before. As the astronauts came back around from the far side, a collective sigh of relief was breathed by many of the flight team at Mission Control in Houston. Charlie Duke, who was the lunar module pilot on the Apollo 16 mission, describes what it was like to be flying over the far side of the moon. In the words of Charlie, "The computer told us that we were out of contact with the Earth and that we had loss of signal. Then, all of a sudden, there was the sunrise. It was the most dramatic sunrise I've ever seen. In Earth orbit, you see the sun's glow on the horizon or the planet's atmosphere, and it gets brighter and brighter. The moon is different, though. There's instant sunlight with long shadows on the lunar surface. The far side of the moon was very rough back there. I would not have wanted to land on the backside of the moon." After the success of Apollo 8, Apollo 9 went back to vital low Earth orbital testing of the lunar module. So the next astronauts to visit the far side were Gene Cernan, John Young, and Tom Stafford, on board Apollo 10 in May 1969, just 2 months before the historic landing of Apollo 11. However, while flying over the far side of the moon, the trio of astronauts encountered something strange, which in the last few years NASA has been forced to re-explain thanks to conspiracy theory documentaries airing on US television. The facts had been well known since the 1970s. These strange events on Apollo 10 were manifest in the form of some very odd sounds. The radio systems on board the Apollo spacecraft were crude by modern standards, though state-of-the-art at the time. The command and lunar modules were relatively noisy environments, according to most of the astronauts, with bumps and bangs combined with the whirring of fans and engine noise. What the Apollo 10 crew heard through the radio systems baffled them. They described it as being almost like that made by an electronic instrument called a theremin, often used in creepy science fiction B-movies of the 1950s and 60s, as well as on the Beach Boys song Good Vibrations. Research has since proven that the sound was nothing more than an interference effect from those 1960s radio communications systems on board. With the onset of the moon landings, 2 astronauts would travel to the surface, while a third remained on board the command module to orbit the moon alone, though all of them got chance to orbit the moon and see the far side before landing. The solo orbital journeys of Michael Collins, Apollo 11, Dick Gordon, Apollo 12, Stuart Roosa, Apollo 14, Al Worden, Apollo 15, Ken Mattingly, Apollo 16, and Ron Evans, Apollo 17, who were the unsung heroes of the Apollo missions, are some of the bravest feats ever achieved by astronauts. They would spend days making quite detailed lunar observations from orbit, mapping features nobody had ever seen before. Al Worden is often quoted as saying that his time alone was some of the best he had during the Apollo 15 mission. According to Al Worden, the far side, the views at certain times when the sun and the earth are blocked out, are like nothing you could imagine. The sheer number of stars you see is incredible. It's like a sheet of white, and you know that every single one of them is a sun in its own right. A question often asked of the Apollo astronauts and flight teams is, why were all the missions just to the near side? In fact, the answer is so simple. As Charlie Duke says, we wanted to be in contact with the Earth, so we weren't able to land on the far side of the moon. Should something have gone wrong while the astronauts were on the surface, they would not have been able to communicate directly with Earth. This would not be such a problem today, as satellites could be put into lunar orbit to relay communications. The far side is of growing interest to scientists and potentially future planned human missions. Indeed, the possibilities for the far side of the moon are vast. For many decades, the astronomical and scientific community has wanted to put radio telescopes and optical telescopes on the far side. Observatories on the far side would be shielded from not only man-made radio interference from Earth, but also the glare of daylight on our planet. The telescopes could be built inside craters to avoid solar radiation, and would provide us with an unprecedentedly clear insight deep into the far reaches of the universe. Otherwise, we also have little true understanding of the processes that make the far side so vastly different in appearance to the near side. Thus, with NASA gearing up to send astronauts to the moon's south pole, there's never been a better time to be a lunatic. The surge of interest in lunar exploration is great news for planetary scientists, hoping to learn more about Earth's rocky sidekick. These are the burning questions they're dying to find the answers to. According to Noah Petro, a research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and a project scientist for the Lunar Reconnaissance Orbiter, the fundamental question of how the moon formed and how that relates to the Earth is really the most important of the unknowns. Everything else comes after that. You can thank Apollo 11 for giving us our first insight into that mystery. The mission brought back 50 pounds worth of moon rocks and initiated decades of investigations focused on learning how the moon formed and evolved. Scientists used them to come up with the strongest existing model, that the moon began as a magma ocean, a giant ball of molten lava orbiting Earth. This in turn led decades later to the hypothesis that the moon was born out of Earth itself, when a giant impact with a Mars-sized object ejected debris into orbit. Further studies of the rock show the material that formed the moon also formed our own planet, adding more support to this idea. That's the most widely accepted hypothesis for the origin of the moon, but it's by no means perfect. There is no way yet to confirm a giant impact created the moon, and our sense of how the magma ocean cooled down into the dry, gray rock we see now is still very hazy. About 10 years ago, we discovered evidence of water on the moon, something that's a bit difficult to reconcile with an impact hypothesis. Getting to the bottom of the moon's past requires the sort of on-the-ground work we've done to unravel Earth's own history. Put the origin of the moon aside, Apollo Moon Rocks continues to challenge our understanding with another conundrum. Why aren't moon rocks as old as the moon? The moon is just over 4.5 billion years old, which makes it a mere 60 million years younger than the solar system itself. The early days of the inner solar system were chaotic and defined by the constant collision of solid materials as they whipped around the nascent sun, gradually forming larger and larger bodies in a process known as planetary accretion. Analysis of the rocks collected by the Apollo astronauts shows that most were created by impact events about 3.9 billion years ago, but almost none of them were dated to the moon's first 600 million years of existence. This is weird because impact events should have become less frequent as the planetary accretion process wound down. so you'd expect to find a lot more rocks formed from earlier collisions. This led scientists to hypothesize that the Moon was subject to intense collisions about 3.9 billion years ago, a period known as the Late Heavy Bombardment, or more poetically, the Lunar Cataclysm. While this theory nicely accounts for the Apollo moon rocks, it also raises a big question. What caused all these rocks to start pummeling the Moon? The leading model suggests that the outer planets used to orbit much closer to the Sun, and as they moved outward, sent big rocks on a collision course with the Moon. But an alternative theory posits that the cataclysm never happened and that the preponderance of rocks dating to 3.9 billion years ago is due to sample bias. The last 3 Apollo missions all took samples from 3 major impact craters: Imbrium, Serenitatis, and Nectaris. New evidence suggests that the samples used to date the age of each of these craters, which is crucial to determining whether a period of heavy bombardment occurred, may actually just be debris from the impact that formed the largest crater, Imbrium, about 3.9 billion years ago. So, the best way to settle the lunar cataclysm debate will be to visit craters where samples aren't likely to have been contaminated by the Imbrium impact, such as the South Pole or the far side of the Moon. If most of those new samples are older than 3.9 billion years, it will cast the theory of the lunar cataclysm in serious doubt and also help scientists better understand conditions in the early solar system. Regardless, interest in the lunar South Pole as a landing site is mainly driven by the fact that scientists know the region hosts lunar water. Indeed, there's water on the Moon, and NASA first found water on the Moon in 2009. But we're not just talking about a little sprinkling of interstellar water. We're talking about troves and troves of water ice that could be sitting just beneath the surface, especially at the lunar poles. This is good news for future expeditions to the Moon, which plan to use this water ice for everything from life support to rocket fuel. But for many scientists, the big question is, how did all that water ice get there? Well, nobody really knows yet. According to Paul Hayne, a planetary scientist at the University of Colorado Boulder, there are 3 main theories for how water originated on the Moon. The most obvious theory suggests that the water ice was deposited by asteroid and comet impacts, where it vaporized and eventually made its way to the poles. It's also possible that ionized hydrogen from solar winds binds with oxygen trapped in regolith and is eventually released as vaporized water due to temperature fluctuations on the surface. Finally, there's a possibility that water was present in the material that originally formed the Moon and was forced to the surface by volcanic eruptions. It could be that all 3 processes were at work, which makes it a question of how much water each mechanism contributed. Luckily, there has been some promising initial data. In 2009, NASA launched the Lunar Crater Observation and Sensing Satellite on a mission to impact the lunar surface at the South Pole. And this mission not only detected the presence of water, but it also identified a mix of other materials that are common in comets, suggesting at least some of the water hitched a ride on space rocks. To get a better idea of how much of the Moon's water was brought to the lunar surface by comets, asteroids, or solar winds, it will be necessary to send a robot or human to take a sample and examine its isotopic composition. That's really the only way we can definitively associate that material with a source. But even if scientists can determine the origins of lunar water, there's still the question of how it came to be concentrated in the poles, a controversial topic, according to Hayne. Currently, the lunar science community is divided on whether water that is vaporized during comet and asteroid impacts can travel across the surface of the Moon or whether it becomes trapped in the regolith. The only way to know for sure is to return for further tests. One of the biggest questions facing lunar scientists is whether the Moon houses alien life. Conspiracies about little green men aside, some scientists believe water stored under the satellite's surface may hold ancient microbes. According to Professor Christopher Palma, an astrophysicist at Penn State, one idea for the origin of life is that its building blocks were delivered by comets. there may be remnants of those in the ice on the moon. Scientists won't know for sure until they send a probe, or human, up to the lunar surface armed with a hefty drill. One enigma that's sprung up only recently has to do with the discovery that something massive is lurking underneath the south pole of the moon, below the largest impact crater ever made in the entire solar system. Scientists have no idea what it could be, but it's certainly big enough to affect the gravitational force exerted by the moon's mass. Predominant theories suggest it's some sort of heavy metal body from a projectile that impacted the surface a long time ago. But this is far from certain, and it's hard to understand what this mass is doing suspended underground. We know the moon's interior is still active to some degree, and heat should have caused this mass to shift around instead of staying trapped like Han Solo in carbonite. Put simply, the moon, once again, raises questions we're just not able to answer yet. Another stunning revelation showed there are earthquakes happening on the moon pretty frequently, otherwise known as moonquakes. Apollo-era seismometers installed on the surface measured these shakes from 1969 to 1977. That data has shown us that the moon is an active body, a far cry from the stale, lifeless rock many assume it is. We're already aware of a few phenomena that cause these quakes, like thermal expansion, tidal stress induced by Earth's gravity, and meteorite impacts. But with such limited data, we're not entirely sure how these processes work and exactly how the quakes behave. Moreover, there are other, shallower moonquakes without any obvious cause, which seem to be occurring more recently than the others. Petro suggests a global seismic network installed around the moon would be tremendously helpful in helping understand the trigger mechanisms behind all this tectonic activity. Such a network could cleanly identify exactly when these events occurred, where they originated from, and the effect they have on the rest of the moon. The 50-year-old data we're using now won't be enough to give us any good answers. In addition, scientists also believe that there's a reason we've only ever seen one side of the moon. It's tidally locked, which means only one side of it faces Earth. This is not uncommon for moons in our solar system, but it's still unclear exactly when this occurs, what conditions encourage it, and how it happens. So, in some scientists' mind, this mystery of tidal locking harkens back to the question of the origin of the moon and what was happening in early lunar history. It's another piece of the 4-billion-year puzzle. What's more, this mystery isn't just local to the moon either. As we continue to find more planets and moons outside of our solar system, it's important to figure out what sort of factors help incite features like tidal locking and decide whether potentially habitable worlds, like the TRAPPIST-1 exoplanets, really are hospitable to life. After all, if scientists can lift the veil on moon mysteries, we could have a better understanding of the solar system's history. The moon lacks much in the way of an atmosphere and hasn't been volcanically active for billions of years, which means its surface has remained relatively unchanged across the eons. In this sense, says Prabal Saxena, a postdoctoral researcher at NASA's Goddard Flight Center, the craters are like the pages of a history book of the early solar system, if only we could figure out how to read them. As mentioned previously, a prevalent theory of lunar formation says that our planetary neighbor was bombarded by space rocks about 3.9 billion years ago. If the samples from the surface confirm that there was a lunar cataclysm, this could also tell us a great deal about how the solar system formed. Not only would it suggest that the outer planets were once much closer to the sun, it would likely mean that the Earth was bombarded too. This would have vaporized any water on the Earth's surface and killed any life that may have existed there. Strangely enough, the moon also appears to have recorded early solar history. Just a few years ago, Saxena and his colleagues used the composition of the lunar crust to determine that our sun likely rotated 50% slower than similar newborn stars during its first billion years of life. The moon and Earth are largely composed of similar materials, but the moon has notably less sodium and potassium. Using this evidence, Saxena and his colleagues ran simulations that showed how solar activity can either deposit or strip the moon of these minerals, and then incorporated data about the relationship between solar flares and stellar rotation rates. According to the simulations, the sun must have been rotating slowly to account for the levels of potassium and sodium observed on the moon today. This data about the sun's early history can also help explain things like how quickly Venus lost its water, how quickly Mars lost its atmosphere, and how it impacted atmospheric chemistry on Earth. As NASA and other space agencies lay the foundations for a permanent human presence on the moon, there will be more big questions to answer, and the moon is really just a small step toward the giant leap of unraveling the origin of everything we know. On July 20th, 1969, Neil Armstrong and Buzz Aldrin safely descended onto the moon in Apollo 11. It was a frightening moment, with alarms firing and gas lines freezing as the astronauts barreled toward another celestial body for the first time in human history. The astronauts landed on Mare Tranquillitatis, a dark, bluish plain made of ancient lava, and for the next 2 hours, they explored the moon's surface, collecting rock samples and bouncing about. It was the first of 6 more manned journeys to the moon between 1969 and 1972. Apollo 13 was the only mission that had to be aborted, with the crew making an emergency re-entry. In 1972, Apollo 17 was the last manned expedition at a time when U.S. interest in lunar landings was fading fast. We'd been there, and now it was time for the next big space adventure. But now, half a century later, scientists have a renewed interest in what we can learn from the moon. According to NASA, the moon continues to be a treasure trove of science, one that might in the future allow for habitation. What's more, the moon turned one side of itself away from the Earth 4.4 billion years ago and never looked back. This cosmic insult has turned the moon's far side into a mysterious, troublesome place where, at least in the imaginations of sci-fi writers and human-hating robot aliens, crashed. That it is so close, yet so unexplored, lends the far side of the moon a shadowy mystique. But now, thanks to the James Webb Space Telescope, we can finally see what lies beyond the horizon, unlocking a new era of lunar exploration and discovery. Join us as we explore the mysterious realm of the moon's dark side, uncovering obscure details and highlighting our celestial neighbor's lesser-known features. From Earth, we only ever see one lunar face, because the moon takes about the same amount of time to rotate once as it does to complete a single orbit of Earth. This is no coincidence. It's linked to our planet's strong tidal influence on our natural satellite. The result is that, more or less, we can divide the moon into 2 hemispheres, the side that always faces us, the near side, and the one that always points away, the far side. Anyone who has gazed up at the moon is familiar with the near side's most prominent features, many large and roughly circular dark patches against a backdrop of brighter terrain. Ancient astronomers dubbed these dark features Maria, Latin for seas, because of their water-like appearance from Earth. But they're actually plains of basaltic volcanic minerals, solidified lava, that erupted out from beneath the surface long ago. The near side's brighter regions are older, heavily cratered, and more reflective highlands that rise from the plains. Astronomers had long assumed the moon's mostly unseen face was similar, but space-age reconnaissance shattered those expectations in 1959, when the Soviet Luna 3 spacecraft beamed back the very first image of the far side. Although it was grainy and fuzzy, the photograph was still clear enough to reveal a wildly different landscape. The far side was almost all rugged highland, with the near side's sprawling Maria shrunken to just a few scattered darker spots. Decades of follow-up observations only widened the shocking mismatch between the hemispheres. For instance, gravity data from the 2 lunar-orbiting GRAIL, Gravity Recovery and Interior Laboratory, spacecraft indicated that the far side's crust was about 20 kilometers thicker on average than that of the near side. Why were the two hemispheres so different? It's tempting to think Earth's tides played a role, yet nothing is ever that simple. The cause must reach back to the moon's birth. The current origin story, widely accepted by scientists, is called the giant impact hypothesis, also known as the Big Splat, which I rather like. In this scenario, a Mars-sized world, which astronomers call Theia, after the Titan who was the daughter of Gaia in Greek mythology, slammed into Earth at a grazing angle shortly after our planet's formation 4.6 billion years ago. The immense release of energy tore Theia apart, sinking its core down into Earth's depths and blasting its outer layers, plus lots of terrestrial material, into orbit. All that superheated rock cooled rapidly in space and became the moon. Scientists still argue over the details, but our satellite may have coalesced from the debris in as little as a few months to a few years. At that time, the moon was much closer to Earth than today, perhaps only about 1/10 the current separation. Across the eons, tidal forces gradually pushed it farther out. At that close distance, the tidal interaction between the two was fierce, and the newly created moon's rotation may have become tidally locked in as little as a year. This is far faster than the crust could have formed and solidified, which means that the hemisphere dichotomy couldn't be caused by Earth's tidal pull. Something else must have happened to thicken the far side as the crust initially cooled. However, scientists tossed around a few ideas. None proved to be a perfect fits for the dichotomy we see today. Perhaps a second, smaller moon formed from the big Splat's debris as well, and it eventually collided with the bigger moon at slow speed and draped the far side with more material. Maybe physical processes churning inside the newborn moon allowed one side to get thicker. Then, in 2014, a team of astronomers published a new, arguably better explanation. Their culprit was not our planet's tides, but Earth itself. In all the models investigating the young moon's evolution, none had completely taken into account that Earth loomed overwhelmingly large in the lunar sky. Shortly after the moon formed, Earth was so close that it would have taken up a staggering 40 degrees of angular diameter in the sky as seen from the moon, covering a celestial area 20 times larger than it does today. Remember, at that time, Earth was hot. Theia's impact would have vaporized much of our planet's surface and melted the rest. For many centuries, if not millennia, the heat from rock, boiling at about 2,000 degrees Celsius, would have cooked the nascent moon's near side, raising it to about 1,000 degrees C, while the far side would have cooled to frigid temperatures. This has profound implications. Early on, when the moon was still entirely molten, it would have had a churning atmosphere of incandescent rock and metal. Hardy elements such as calcium and aluminum have a very high boiling point and would have stayed as gas on the moon's roasting near side, whereas they would have easily condensed on the cooler far side. Those windswept elements would have interacted with others on the far side, forming relatively lightweight minerals such as feldspar, which would have floated on the surface to gradually create that side's thicker crust. Interestingly, orbital surveys do show more feldspar on the far side than on the near side. Also, this process could have concentrated other minerals on the near side, including radioactive ones that would have acted to heat the crust there and allowed magma to eventually burst forth. This would have flooded much of the near side's surface to make the dark Maria while leaving the far side mostly Maria-free. So, does this solve the mysterious lunar dichotomy? It's the best idea going right now, but of course more evidence is needed to support it. And James Webb may provide some clues. The technological achievement of NASA's time machine is uncontroversial. It's set to take the success of the Hubble a step further. What we get now is a telescope that's about 100 times more powerful than Hubble. The Webb's biggest advantage is the type of light it collects. Light comes in a lot of different varieties. The human eye can see only a narrow band known as visible light, But the universe contains lots and lots of light outside this range, including the higher frequency, higher energy forms, ultraviolet, gamma rays. Then there's the lower energy light with longer wavelengths, infrared, microwaves, radio. The Hubble Space Telescope collects visible light, ultraviolet, and a little bit of infrared. The Webb is primarily an infrared telescope, so it sees light that's in a longer wavelength than what our eyes can see. This seems nerdy and technical, but it's actually what allows Webb to look further back in time than the Hubble. Infrared light is often very old light due to a phenomenon called red shifting. When a light source is moving away from a viewer, it gets stretched out, morphing into a longer and longer wavelength, growing redder. The opposite is true as well. As a light source grows closer, the wavelengths shorten, growing bluer. It's similar to what happens when a siren goes by. The pitch increases as the siren approaches, then decreases as it trails away. Because space is constantly expanding, the farthest things away from us in the universe are moving away from us. Imagine a star that's really far away. The light from that star may start off in the visible spectrum, but it gets stretched on its journey to us. It grows redder and redder. Eventually, these very distant old galaxies grow so red that they drop into the infrared spectrum. Webb can see this ancient light that has become invisible to the human eye. Conveniently, infrared light has other uses as well. It's a really good type of light to use to look at exoplanets. For instance, if you were on a planet that orbits another star and wanted to see Earth, visible light wouldn't be your best bet. That's because the Earth peaks in the infrared. So, if we want to be able to study an Earth-like planet in another solar system, what we really want to do is observe at infrared wavelengths, because that's where the light from the Earth is being emitted. And in a recent discovery, scientists have for the first time discovered a cave on the Moon. What's interesting, it is just one in probably hundreds of caves hidden in an underground, undiscovered world. And that's a piece of good news. Anyway, countries are racing to establish a permanent human presence on the Moon, but they will need to protect astronauts from radiation, extreme temperatures, and space weather. And at least 100 meters deep, the newly discovered cave could be an ideal place for humans to build a permanent base, and suggested humans could potentially be living in lunar pits in 20-30 years. That's convincible. After all, life on Earth began in caves, so it makes sense that humans could live inside them on the Moon. Fascinatingly, it is visible to the naked eye from Earth, and is also where Apollo 11 landed in 1969. The cave has a skylight on the Moon's surface, leading down to vertical and overhanging walls, and a sloping floor that might extend further underground. It was made millions or billions of years ago, when lava flowed on the Moon, creating a tunnel through the rock. The closest equivalent on Earth would be the volcanic caves in Lanzarote, Spain. The cave has yet to be fully explored, but the researchers hope that ground-penetrating radar, cameras, or even robots could be used to map it. The future research of that cave may also help us explore caves on Mars in the future. That could open the door to finding evidence of life on Mars, because if it did exist, it would almost certainly have been inside caves protected from the elements on the planet's surface. The Moon cave might be useful to humans, but the scientists also stress that it could help answer fundamental questions about the history of the Moon and even our solar system. The rocks inside the cave will not be as damaged or eroded by space weather, so they can provide an extensive geological record going back billions of years. But besides the Moon, James Webb also focuses its sharp eyes on moons outside the solar system. These are known as extrasolar moons, or simply exomoons. Thus far, exomoons have proved an elusive subject for astronomers because they are hunted using the same light-blocking technique employed to spot exoplanets around stars. However, this technique is difficult enough when looking for large worlds beyond Earth. Searching for little exomoons with it is immensely challenging. Not only would exomoons block far less light than the exoplanets they orbit would, but they'd also need to be in the right position at the right time. An exomoon that's detectable would have to be orbiting its planet precisely as that planet's crosses, or transits, the face of its parent star to obscure some light when viewed from our vantage point in the cosmos. That obstruction would be detected by scientists' equipment, which would allow them to reverse calculate that an exoplanet, or potentially exomoon, gave rise to it. But now, with James Webb's near-infrared imager and slitless spectrograph, or NIRIS for short, scientists can make the first undisputed detection of an exomoon. This is hopefully just the beginning of the exomoon revolution. New worlds that will surely hold some remarkable secrets. Of course, Webb's Cycle 3 GO projects also include a wealth of investigations focusing on exoplanets themselves and not just their potential moons. This includes a few that wish to determine whether some exoplanets have the conditions needed to support life as we know it. Among those exoplanet habitability projects is one called Constraining the Atmosphere of the Terrestrial Exoplanet TOEI 4481b. This will use Webb's MIRI instrument for 16 hours to determine if a roughly Jupiter-mass exoplanet, which orbits a star around half as massive as the Sun that sits some 39 light-years away, has been able to hang on to its atmosphere. The result could serve as a first step in understanding the habitability of rocky planets and establishing whether M-type stars, also known as red dwarfs, have terrestrial planets with significant atmospheres. This is important in the search for life beyond Earth because red dwarfs are the most common stars in the Milky Way. In addition, supermassive black holes are getting in sight of James Webb. Astronomers widely believe the majority of our universe's large galaxies have supermassive black holes in their hearts, with masses as great as millions or even billions of suns. Some of these supermassive black holes are actively swallowing gas and dust that surrounds them in disks of matter called accretion disks. These monster black holes' gravitational influences are thought to heat the material in those accretion disks, causing them to emit bright radiation across the electromagnetic spectrum and create regions called active galactic nuclei, or AGN for short. Additionally, any matter that isn't swallowed by the black hole can be channeled to its poles, where it is blasted out as jets of particles traveling at speeds approaching light. When that happens, the phenomenon is a called-a-quasar. The violent conditions of these events make AGNs and quasars the brightest objects in the universe, often luminous enough to outshine the combined light of every star in the galaxies around them. Our theoretical understanding of supermassive black holes has burgeoned since the Event Horizon Telescope revealed the first image of a black hole, the supermassive black hole at the heart of the galaxy, Messier 87, in 2019. And James Webb's Cycle 3 missions will further contribute to this knowledge. The Webb Cycle 3 supermassive black hole observation programs include the investigation of quasars in the early universe and the nature of the first black holes. Scientists hope to understand how those black holes may have influenced the growth of galaxies over billions of years. The observations of supermassive black holes in the early universe, made by the Webb telescope, could also reveal how these cosmic titans grew to the tremendous masses scientists observe before the universe was even 1 billion years old. Such a question can be answered by using MIRI to investigate if a giant molecular cloud that existed around 13.2 billion years ago could have directly collapsed, birthing a heavy black hole seed that would account for a rapid growth mechanism. One of the primary roles of James Webb is investigating objects in the early universe. The powerful space telescope has this capacity because the expansion of the universe stretches wavelengths of light from distant objects as this light travels toward us, moving the wavelengths toward the red end of the electromagnetic spectrum. The longer that light has traveled to reach us, the more red-shifted the light has become. This means light that has been traveling for around 12 billion years is extremely redshifted all the way into the infrared region of the electromagnetic spectrum and outside the visible range we can see with the unaided eye. Effectively, infrared light is invisible to us. However, the observatory is capable of observing this infrared light, and thus helps to investigate the first stars and earliest galaxies, something it will continue to do in 2025 with several Cycle 3 GO projects. Though James Webb was designed with the study of distant objects in mind, its next mission will also see the observatory used to study bodies within our own solar system. These will include hunting for the source of gas plumes coming from Saturn's moon, Enceladus, investigating the dynamics of the Uranus's rings, and characterizing icy objects that exist in the Kuiper Belt at the very edge of the solar system. These studies attract even more attention when scientists have long theorized that both Enceladus, one of Saturn's 146 known moons, and Europa, one of Jupiter's 4 large Galilean moons among its total 95 moons, could host vast liquid water oceans that harbor life. If this is the case, then complex organic molecules like amino acids and nucleic acids, the building blocks of life as we know it, could serve as biosignatures of life on the worlds. The problem, however, is that both Europa and Enceladus are bombarded by harsh radiation from the sun that could potentially destroy complex organic molecules at their surfaces. But new research offers some hope on this front, suggesting that those biosignatures could indeed survive if they're preserved in the icy shells of the moons. And if that's true, these molecules could sit so close to the surface that future robotic landers may be able to dig them free. At Enceladus, in fact, this digging might not even be needed. Biosignature molecules could survive in shallower ice than on Europa. As research leader Alexander Pavlov of NASA's Goddard Space Flight Center in Greenbelt, Maryland, said in a statement, "Based on our experiments, the safe sampling depth for amino acids on Europa is almost 8 inches, or 20 centimeters, at high latitudes of the trailing hemisphere, the hemisphere opposite to the direction of Europa's motion around Jupiter, in the area where the surface hasn't been disturbed much by meteorite impacts." Subsurface sampling is not required for the detection of amino acids on Enceladus. These molecules will survive radiolysis, breakdown by radiation, at any location on the Enceladus surface less than 1/10 of an inch, or under a few millimeters from the surface. In short, James Webb is opening a new era in astronomy. Astronomy as a field aims to answer big yet fundamental questions about our place in the universe, so it is perhaps most apt to start this list with a bombshell discovery 25 years ago, on April 15, 1999, when astronomers found the first planetary system outside our own. In the past 25 years, astronomers also discovered hundreds of free-floating worlds that challenge the definition of a planet, the long-sought God particle, ripples, in the fabric of space-time, the sun's missing neutrinos, the first real clue about the nature of dark energy, and a lot more. Here's a look back at the most amazing astronomical discoveries of the past quarter century. 1. First planetary system outside our own. In April 1999, astronomers found a trio of Jupiter-sized planets circling the sun-like yellow-white star Upsilon Andromeda A, located roughly 44 light-years from Earth, the first extraplanetary system ever to be discovered. The discovery disproved the notion that our solar system was a singular phenomenon in the universe, and offered compelling evidence that the discovery of other planetary systems was only a matter of time and technology. In 2010, astronomers also found that unlike the planets in our solar system, the Jupiter-sized planets in this extrasolar system do not orbit in the same plane. Rather, two are inclined by 30 degrees with respect to each other, the first such orientation ever spotted, which helps astronomers refine theories of planetary formation and evolution. As of April 2024, astronomers have found close to 900 stars that host 2 or more planets. 2. First free-floating planet in the Milky Way. At the turn of the 21st century, astronomers detected the first free-floating planet hovering by itself in the nearby Trapezium cluster, a stellar nursery near the heart of the Orion Nebula. In our galaxy alone, there may be as many as a quadrillion of these rogue planets, which are kicked out of the star-circling disks of gas and dust in which they are born. However, only a handful have been found cruising through our galaxy. Because they are ultra-faint, they are difficult to spot. The orphaned planets are the lightest products of a star's birth and important carriers of information about the environments where they formed. First exoasteroid belt outside solar system. In early 2001, NASA's Spitzer Space Telescope found evidence of the first asteroid belt outside the solar system around the nearby Sun-like star HD 6983, located roughly 40 light-years away, in the constellation Puppis. The belt is estimated to be 25 times more massive than the main asteroid belt between the orbits of Mars and Jupiter. In 2005, astronomers discovered 3 Neptune-like planets orbiting this star, with the outermost planet possibly within the star's habitable zone. Astronomers are interested in the size and location of asteroid belts in multiplanetary systems, as the rocky shards influence the coalescence of planets and even the emergence of life. In our own pocket of the cosmos, a leading theory posits that asteroids delivered water and organic compounds to early Earth, which is supported by recent detections of water molecules in asteroid samples returned to Earth as well as a couple in space. 4. Mystery of sun's missing neutrinos solved after 30 years. In June 2001, physicists announced that they had found the sun's missing neutrinos, subatomic particles that have no charge and practically no mass. The detection ended a 3-decade-long search for the tiny packets of energy, but implied they must have a bit of mass. Nuclear reactions at the sun's heart, the same process by which the sun shines, produce billions of neutrinos, half of which were estimated to make the 93 million mile or 150 million kilometers journey to Earth. But experiments during the late 1960s detected too few of the ghostly particles, a discrepancy that came to be known as the solar neutrino problem. In 2001, experiments from the Sudbury Neutrino Observatory in Canada revealed that the missing neutrinos had, in fact, merely transformed into 2 other types of neutrinos on their way to Earth and escaped detection. This transformation demands that the ubiquitous neutrinos possess some mass, now estimated to be hundreds of thousands of times less than the mass of the next lightest particle, the electron. 5. First exoplanet blanketed by an atmosphere. In November 2001, astronomers entered a new phase of exoplanetary science when data from the Hubble Space Telescope revealed for the first time the presence of an atmosphere blanketing an alien world. The exoplanet, HD 29458b, is located 150 light-years away in the constellation Pegasus. It was the first of many exoplanets now known to host atmospheres ranging from vanishingly thin to very dense, like Jupiter's. The discovery sparked a new era in exoplanet exploration, as astronomers could begin to compare exoplanets' atmospheres, including the abundances of atmospheric gases known to emerge from life on Earth. 6. Fast radio bursts reveal the universe's missing mass. In 2007, astronomers using the Parkes Observatory in Australia discovered a fast radio burst known as FRB, a bright, incredibly short burst of radio waves from a galaxy billions of light-years from Earth in just milliseconds. The intensely bright pulse, named Lorimer Burst FRB 10724, blasted into space as much energy as the Sun does in 80 years. Since then, hundreds of such intensely bright pulses have been detected from faraway galaxies scattered across the universe, including a few that seem to erupt repeatedly and irregularly. Astronomers have used the intense pulses to find some of the universe's missing matter, which lurks in spaces between galaxies and was detected by studying the dispersion of radio waves from FRBs as they traveled through interstellar gas. 7. Discovery of the Higgs boson, the God particle. In July 2012, the field of particle physics captured the global spotlight with the discovery of the Higgs boson, a long-sought subatomic particle that pervades the universe as a field that gives other elementary particles their masses. The existence of the Higgs boson was first predicted independently by physicists Peter Ware Higgs and François Englert in 1964, close to half a century before it was found by two experiments at the Large Hadron Collider in Switzerland, which detected the God particle within just 2 years of beginning operations. Higgs and Englert received the 2013 Nobel Prize in Physics for their theory of how particles acquire mass. 8. Detection of gravitational waves confirms Einstein's theory. In February 2016, scientists using the Laser Interferometer Gravitational Wave Observatory announced that, in September 2015, they had detected gravitational waves, faint ripples in spacetime predicted by Einstein a century ago. For the first time, when those that emerged from colliding black holes washed over Earth. Because these waves traveled unscathed through sizzling matter of the early universe, their detection heralded a new way of studying the universe that was never possible with electromagnetic waves. 3 astrophysicists who helped detect the gravitational waves, Rainer Weiss, Barry Barish, and Kip Thorne, won the Nobel Prize in Physics in 2017 for their work. Another new era in gravitational wave astronomy began in June 2023, when scientists with the North American Nanohertz Observatory for Gravitational Waves Collaboration revealed compelling evidence for the presence of a faint but persistent hum of gravitational waves pervading the universe. They strongly suspect the hum, which, at 1/1,000,000th of 1 Hz, was a few hundred times fainter than the gravitational waves detected in 2015, represents a collective echo of supermassive black hole pairs circling each other in orbits that shrink across millions of years. 9. First interstellar visitor spotted in our solar system. In fall 2017, astronomers spotted a strange object zipping through our solar system, the first known interstellar visitor. The identity of the object, dubbed Oumuamua, was shrouded in mystery because its brightness varied more than what would be expected from an asteroid, and it didn't act like a comet. As such, it sparked arguments, with some speculating that it might be an alien artifact. First considered an asteroid, Oumuamua was recast as a comet in 2023, with one group of astronomers suggesting it was likely ejected from an extrasolar planetary system and accelerated by tiny amounts of hydrogen gas emerging from the object's icy heart. In 2019, astronomers found the second interstellar visitor, Borisov, which was soon confirmed to be a comet, thanks to its telltale gaseous coma. The rogue object, which never passed near a star until visiting the Sun, is considered the most pristine comet ever studied. 10. First image of a supermassive black hole. In 2019, astronomers photographed a black hole for the first time. The Event Horizon Telescope project imaged the contours of the monster black hole lurking at the heart of the Messier 87 galaxy, which is located over 50 million light-years from Earth. The image opened up a new way to study black holes and was likened to the first illustrations of what insects and plants look like through a microscope. In 2021, astronomers unveiled a new image of the object that shed light on how magnetic fields behave close to black holes. In 2023, the black hole image got an AI makeover, which turned the fuzzy orange donut into a skinny ring. Astronomers also found that the black hole is spinning, although the rate of spin remains unclear. 11. The most detailed map ever of Milky Way. The most detailed map ever of the Milky Way plotted in 3D nearly 1.8 billion stars in unprecedented detail using data from the European Space Agency's Gaia spacecraft. As mind-boggling as the 1.8 billion stars may be, they represent just over 1% of our entire galaxy's stars. Astronomers say studying the motions of these plotted stars could reveal long-sought clues about the nature of dark matter. 12. First starless, empty galaxies. In January 2024, astronomers announced that they had spotted a primordial galaxy that is so diffuse that it hasn't formed stars. The discovery challenges leading theories of how galaxies form and evolve and even the conventional definition of a galaxy. After all, what is a galaxy without stars? The same week, a different team reported the discovery of another almost empty galaxy called Noob, which is Spanish for cloud. Unlike our galaxy's central bulge, Noob is puzzlingly uniform and intriguingly isolated roughly 300 million light-years from Earth. Its closest large neighbor is at least 1.4 million light-years away. Such dark galaxies, which were once thought to outnumber all visible galaxies, shine hundreds of times fainter than the Milky Way, whose light is powered by roughly 100 billion stars. Astronomers continue to puzzle over why these ghost galaxies lack stars, even though they contain pristine star-forming gas. 13. Dark energy may be evolving. Physicists have long considered dark energy, the mysterious force driving the accelerated expansion of the universe, a cosmological constant, meaning it remains constant throughout the history of the universe. However, in April 2024, astronomers who created the largest 3D map of the universe suggested that dark energy may be evolving with time. The discovery might be the first real clue about the elusive phenomenon in the past 2 decades, and one that would be as revolutionary as the discovery of the accelerated expansion of the universe itself, if confirmed with future data, scientists said at the time. 14. James Webb's revolutionary discoveries. Astronomers have long wondered just how the universe resurfaced from the cosmic dark ages, when the cosmos was cloaked in dense fog of neutral hydrogen gas, to make way for the first starlight. In early 2024, astronomers using the James Webb Space Telescope revealed dwarf galaxies that existed in the first few 100 million years, packed enough punch to flood the early universe with its first light. The discovery is a remarkable testament to the telescope's unprecedented infrared capabilities that allow it to collect light from the faintest objects. Webb's amazing discoveries and breathtaking views have stunned the world since the observatory began operations in 2022. For instance, the telescope captured the pillars of creation, revealing in stunning detail both the colorful tapestry of the dusty cloud formation and the cosmic processes occurring in the region. As astronomer Derek Ward Thompson put it, the image can be likened to taking the X-ray of a human. James Webb continues to awe astronomers and the public alike with its detailed images of the most distant galaxies in the universe, faraway supermassive black holes, exoplanets, and more. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.